All right, in bell work today, we are listing the possible rational zeros of the polynomial and then finding the 5 roots. We know there's going to be 5 roots because it's next to fifth. Use your calculator if necessary. This would be a good skill to have on your test or your quiz coming up this week. Use your calculator, okay? I still want to see every bit of work, but by using a calculator, we're going to be able to see things a little bit better. So up here in the corner, I graphed this thing based off of that graph, and you got to make sure your labels are correct. That's -3, and that's +2, because otherwise you might be going for a while. Okay, if you're just plugging in 1 and -1 and x to the 5th polynomial, that's pretty tough. Okay, being able to type that in and being able to play around with your Zoom, that's not something I'm going to teach, but if you're smart enough to figure that out, I'm perfectly happy with you doing that. All right, we're setting up synthetic division. 1, bless you, -1, -4, 8, -32, 48. Normally, I would say do our P's and Q's and work from there. But based off of that picture, it's going to help me out a little bit. What value do you think I should plug in first? I could plug in -3, but that's a little bit bigger. I don't know. I like getting rid of the easy ones first. If I'm doing synthetic division, I'm going to do 2. But you could absolutely do -3. Did all of you do -3 first? All right, I'll do -3. That's fine. Drop the 1. Multiply. Add. Multiply. Add. Multiply. Add. 48. 16. Yay, I did math correctly. I got 0. I knew it was going to be 0. I looked at my picture. I saw I was going to cross it 3. Okay. Once I've tried -3, that got me one of my answers. Okay. That got me one of my answers. What number should I try next now that I know -3 works? Let's jump right into 2. So we're going to do synthetic division. When I know it's going to work, I just jump right underneath it. And I'm going to work right below. That way I don't even have to write it again. That's how lazy I am. Okay, so I'm going to try 2 this time. I drop the 1. I multiply. I add. I multiply. I add. Multiply. Add. Multiply. Boom, I get 0. Okay, great. 2 is a root. We already knew it was going to be a root because we looked at the picture. This was an x to the 5th polynomial. When I did division, I got x to the 4th. When I did division, now this is x cubed. Still don't know how to solve an x cubed. Okay, I still need some other method to get us going a little bit more. I got to keep doing synthetic. And so a little bit rough, and looking at that picture, it only looks like I've got 2 answers. But what other number should I try here? 2. Kevin, why can I try 2 again? It has a multiplicity of 2 because it is touching that x-axis right there at 2. We know it's touching at 2. That means the multiplicity is 2. And so we're going to get that answer again. And so now I'm doing right underneath here. I'm going to jump in and do 2. Bring down the 1. Multiply. Add. Multiply. Add. Multiply. Add. Yay. This is now an x squared polynomial, which is where we want to head to. We're at x squared now. Great. This is x squared plus 0 x plus 4, or just x squared plus 4. I got to solve it. So I could either factor. In this case, I'm doing the pretty straightforward. Take that thing, set it equal to 0. Square root, square root. What am I going to get there for my last 2 answers? That is plus or minus 2. I do not forget the I with that thing, since I'm taking the square root of a negative number. It gets me an imaginary answer. That is where we're headed today. Today we're going to talk about complex answers, answers with imaginaries. We're not getting crazy deep with it, but we're going to do some basics. Okay, normally if this were an Algebra 2 class, you'd spend 4 days doing complex. Okay, today we're doing 1 day. Okay, so make sure we're locked into what we're doing. But my answers are plus or minus 2i, -3, 2, and I just write 2 again. You could write 2 with a multiplicity of 2. I'm just going to throw it twice. Questions on bell work? It's everything we did on Friday.